What's up, people? This is the second part of the functional state machine video. If you haven't seen the first part, the link will be in the description somewhere, maybe. Please watch that video first before watching this one. And if you want to have access to this code, please look at my Udemy course or my Google Classroom course. I'll have the source code for this file in those courses if you want to follow along, but you don't have to have the source code. You can just kind of watch this video and figure it out. Okay, so like I said in my last video, we have a game with Kenny's assets. You can run with the move buttons, hold on shift to walk, and then press the space bar to jump. And we are going to tidy up the nested if statements with a functional state machine, finite state machine, to make it more readable and to make it more understandable. All right, so first things first, let's create an enum. I'm going to say, if you don't know what an enum is, I've created a video explaining what an enum is in Haxe. There'll be a link for that in the description as well. So yeah, just follow along or pause this video if you don't know what one is. Go and watch that and then come back, and then this will make a bit more sense. Let's create an enum called states. And we have two states, like we said before. We've got grounded and jumping. Of course, you can have more. You can have nested states, but for now, we'll just leave it as this. And then we're going to create a new method. We'll put it, say, above the movement one. So we'll call it movement states. Okay. And this is going to be the crux of what's going to take place inside our code. So we are going to have switch, which is standard for our, actually before we make the switch, we need to make a variable here. So we need to have a default state. So we're going to have a variable here called player states, and that'll be of type states. We don't actually need to have this type because state inference will take care of that. So we'll be grounded by default. So when you first start the game, sorry, I said state inference, I meant type inference, but anyway, when you first start the game, the player will be in the grounded state. So we will have this player states, copy that, make that our main argument in our switch. And then we'll have two cases, of course. We'll have case grounded and case jumping. Cool. So now let's populate this with what will determine these states. As before, in a state machine, you need to go to the next state based on what the previous state is. So at some point, we're going to go to jumping here, and at some point here, we're going to go to grounded, but we need to evaluate what conditions need to be met before we change states. So let's add some variables here to kind of help me create this. We'll get this jump variable. At some point, we're going to not have this movement. Actually, we will have it, but it'll be a lot less than it is now. So we'll get this jump variable. I'll cut it and paste it here. And I'm going to say, actually, I need another variable, final, which will be this one because I use it quite often. So I'll probably call it, what's the best name for it? Touching floor, something like that. Oops. Yeah. So basically, for the player to be jumping, so the grounded, for the player to jump, they have to press the jump button, and also be grounded, so they have to be touching the floor. And once those conditions are met, then the player state, or player states, did I call it states? Yes, player states, it should be just states without the S. Player state will be, jumping, but it's not that simple. Because when you hit the button, we have to make sure the player is actually jumping. So we need to get that velocity x here. So we hit the jump button, the player jumps, and then switches state to jumping. So now when they're in the jumping state, what happens? Well, they're in the air and they need to come back down to, at some point they need to come back to the grounded state, right? But not immediately. So they only come back to the state once they're touching the ground. So if the player is not touching the floor, no, actually, if the player is touching the floor, then they have to come back to the grounded. So yeah, I hope that makes sense. So when the player hits the jump button, and they're not touching the floor, they're in the air, they go to this state. When they're in this state, they don't switch to the grounded state until they are touching the floor. So that's the main logic of our state machine. We need to somehow get all this stuff into it as well. So let's create a method. We're going to call this method grounded enums. So grounded animations. And this is going to take care of all the stuff we have here. So we will grab these three, I'd say. Okay. Left, right, and walk. And we're going to say if left and right is pressed. So that is essentially this one. Actually, let's just take all this stuff here and then we'll clean it up a bit, because I'm trying to make sense of the nested if statements, which don't make sense at the moment. So if left and right is pressed, we need to play the walk animation. If they're walking and they're not walking, we'll play the run animation. So we can use the ternary for that. I haven't made a video yet on ternaries. I might by the time this video is made, but it's essentially an if statement written with funny syntax in one line. So basically, if this is true, then do that. If it's false, then do that. What we're going to do is amend this one. Actually, I don't need this anymore because it's already inside the state machine. We will also grab this one, movement states, and switch that here. And we'll put our grounded animations inside grounded. Oops. Okay, so these will be playing once the player is grounded. Once they jump, it will switch here and it won't be playing these grounded animations. It will paint the, no. Okay, it will need to play the jump animation, which is here. So grab that, play the jump animation here. And then there's something I want to do about this mess over here. So we don't need any of this stuff anymore. Starting to look a bit cleaner now, isn't it? Right. So as you can see here, we have walk. This no longer has access to walk, and it doesn't have access to left or right anymore. So to fix that, what we're going to do is make these kind of global, not global, just global to this class. So make them global variables, and we'll put them at the top here. Okay, so they have to be variables because they'll change, and these are booleans, and by default, we need to update them to make sure that we know the player has pressed the button or not. Putting them up here will not update them, so we need to put them down, of course, into the update methods down here, and we can get rid of the vars, the var keywords. Okay, so now whenever the player presses the button, these initialized variables will change, but by default, let's make them false. Okay, do the same for that one too. Yeah, so I hope this makes sense. By default, they're false, and this will check to make sure the player has pressed the button, and when they have pressed the button, it'll be true. So now these two variables at the top, left and right, can be accessed by any single method we have. So this can access them, this can access them, and so forth. So we're going to use this movement variable, method, inside both the grounded and the jumping state, because it needs to determine how much movement the player has. But when the player is jumping, they have a constant movement speed. And when they're grounded, the movement speed is changed based on if they're walking or if they're running. So in order to address that issue, let's create an argument called speed, which will be an int. And we're going to make sure that this benefits from that speed argument. We can tidy this up with a lot of ternaries, I guess. We're going to have velocity x, and that will be, if the right button's pressed, then speed will be whatever the speed is inside here, else it will be minus the speed. And same for the facing. So if the right button's pressed, let's change that a bit, learn to spell, the FLX object, the direction the player's facing will be right, and if it's not pressed, it will be left. So we'll grab that, didn't take the F with me, and then make that left. There we go. So as you can see, that is already a lot cleaner. So this will change based on the speed, and the speed for the jumping, as you said here, would be constant. And I'm just going to grab the speed constant at the top here, which is 250. And similarly, we are going to do the same for the movement, but of course it'll be slightly different. Okay, so it looks like we have the speed variable, sorry, the movement method inside here. So we put it inside here, and the speed will change based on if they're walking or running. What is it doing? It should indent my code properly. Anyway, so we've got this, and we've got walk. If it's walking, it will have the walking speed, and if it's running, it'll have just speed. So now let's put my code correctly indented, and I think that is it. I know I've just kind of gone through everything really quickly and looked at my notes at the same time, but let's have a recap of what we've done. So we've created this moving states method where we've put both the jump variable and it created a new one called touching floor because we used that multiple times into this, and we created a switch based on the player state, which is our enum, which will be our enum states. This is essentially our state machine. So if the player is grounded, so by default the player will be grounded, it will just play the animations, which are these. So if the player presses left or right, depending on if the walk button is pressed, they'll walk or run, and now the speeds accordingly. If they don't press that, they'll be idle. So that's what's going on when the player is grounded. Whenever the player presses the jump button initially, it will change the player's Y velocity, so make the player jump up, and then change the state straight after that to the jumping state, which will move according to a set speed, so not a very varied speed like here, and then play the jump animation. Now this will happen until the player touches the ground, and it will jump back to this state, and it will do what it was doing before. Okay, the movement method has been greatly trimmed down to take a speed argument, and will only move the player if either the left or right button is pressed and not both at the same time. So I think it will have a velocity Y, but it won't have a an idle. So it might make sense to have an idle animation here, but for now we'll leave it. When the right button is pressed, the player will move according to a certain speed. If the left button is pressed, they'll move according to another speed. So they'll move one direction and they'll move the opposite direction. Similarly, they'll face a different direction as well. So let's test that, see how well that worked. Okay. So as you can see, the player's moving. When I jump, the player jumps. When I hold on to shift, the player walks. And when I jump and hold on to shift, the player doesn't slow down. Now there is one bug that I've noticed, and it's if I jump and let go of the key, the player will jump to the other side. So in order to fix that, let's go ahead and change this from a ternary, because the way that's working is basically when the right button's pressed, the player's moving in the speed, and when they let go, it will do the opposite. But we only want it to do the opposite when the left button's pressed. So let's make this an else if. Sorry about the lighting, it's just changing on my mirror. It's sorry on my video, it's a bit bad. But anyway, just have a right here, and then we're going to have else if left, like so, and then we can have here. So this should just be speed. So let's copy both of this and paste it here. So that will just be speed as normal, and that will be right. Okay, I'm sure there's a better way of doing this, but anyway. And then this will be minus speed, like so, and that will be just left. Okay. So now whenever we jump and hold on to button and let go, it won't jump to the other direction. It will stay where it was before. So that's it. So we've added a simple finite state machine using enums. There's another way you can do it in HaxeFlixel, and that is using the FSM add-on. So someone's created an add-on to make it easier to do this, and I'm going to go through that in the next video. Thanks for watching.